graphing. You go into My Math Lab, and you go to Tools for Success. And on Tools for Success, you slide down, not all the way to the bottom, but about 2/3 of the way down, and click on Use the Graphing Calculator Tutorial. Now there's a manual also, but the tutorial actually is interactive. So you go to the Graphing Calculator Tutorial, click the blue link on the page it takes you to, and this takes you through everything you need to know how to do. Right now, probably one of the things you want to do the most to be graphing. So let me say graphing a linear function, and it says hit y equals, and it highlights the y equals button, and then you're going to graph y equals, or f of x equals 3x minus 2. So you hit 3 and then x and then subtract and then 2, and then it says now you press zoom, so you press the zoom button, and it says 6, so you're going to press the number 6 button, which is going to select the standard window, which goes from -10 to 10 for both x and y.
So it's not the calculator on My Math Lab, right?
Yeah, that's the one on my, now this is a tutorial. You can't just use it as a calculator. It won't let you do that,
Oh, okay.
okay? It won't let you do that. You will have to have a regular calculator for that.
I have a
But-
program on my computer that, like this one,
Okay.
so.
That does the TI-84?
It looks just like this thing, the virtual calculator.
Okay.
So,
Let me know where you got that, because I've got one too, but mine's probably a little different from yours, so yours may be better than mine. I'll have to look into being able to get that. Was it free?
I got
Okay.
it off Google sites.
Okay, sounds good. And we can kind of share information. I'm all about free.
Oh, yeah, me too.
Okay, so that's how you get to the Graphing Calculator tutorial. And just a reminder, you can get to your textbook by clicking eText and click the link. You don't need to have a special reader if you're on a PC. You can just do it straight from here. You can also read the textbook on the iPad with the Pearson app. And I think it will let you mark up the textbook, but I know this one will. So we're going to go to chapter 1, for example, and we're in chapter 1, section 1. And one of the things I want you to notice is at the beginning of each section, there is actually a video link, and this will help you get ahead, where you can actually go through the videos for that. And I told y'all to go ahead and watch the video for section 1.1. So it will step you through examples just like if we were in class. Let's see if I can get the sound up here.
Find an equation of the line
Oh yes,
R
he talks
that
loud.
passes through 6, 2 and is parallel to 2x plus 3y.
Okay, now we don't have to do that
example.
example, but he'll
Find
talk
the
you through it,
equation of the line
and do
R.
step by step.
Since we already know a point on the line, we need to know its.
So it's good to know that that's there too. And you'll find that most of my lectures, my PowerPoint examples come out of the book. I do the ones in the book. Some people can read the book and understand the explanation. Some people need me to work it out on paper. When I'm in class, I may cut away from the PowerPoint and work the problem on the overhead so that I can actually slow it down for you to be able to take notes. What you do want to do is you want to go ahead and print out your chapter 1 notes and have them so you can take notes every day.
May I ask you a question on the assignment setup?
Mhm.
Because last night when I was doing my homework, and I went in and I saw that there was 2 things that are due today, 1/24/17.
Okay.
And I was trying to do them, but the one thing that we're learning today was that
Mhm.
section 1.2, and it just, of course, I didn't know anything about it really.
Are you talking about Shelby or My Math Lab?
My math lab.
Okay, I've got to adjust some due dates in My Math Lab because of trying to get
Okay.
everything started.
Okay.
And I'll always do that. If you see that a due date's coming up and you feel like we're not really ready for that, don't hesitate to send me a text or a reminder and say, Miss Flint, the homework's due tonight. We just finished that in class today. Can you give us another day or two? And I'll always, try to honor
Okay.
requests like that. And I'll do it for everybody, not just one student. Yes, sir.
I just wanted to make sure we didn't have to do the chapter 1 skill review homework.
You do not have to do the skills review homework. You can, but you don't have to. What I want you to do is do the skills check quiz. If you can get to the mandatory, was 80% that it sets up to? 80 or 85? And I can change that if 85 starts to be a problem, I can cut it back to 80% for people that, you know, are trying, but they're not getting there fast enough. If you can't get to the cutoff mark on the quiz because you keep missing this particular problem, go to the homework, open up the homework and find that kind of problem, because in the homework, you can do the show me an example or help me solve this and see how to work it. And then go back to the quiz and work that problem, okay? The homework is only there to let you do that. So if you can't actually ever get to the, you know, I don't think there's a time limit on the quizzes, is there?
I don't think so, no.
I thought I took it off. There's one class I still have to go in and take it off, but I'm gonna take the time limit off on the quiz, because if you've got enough time, you ought to be able to get the quiz done, even if you need in the middle of it to switch over and work a homework problem or two. When, on the day of the test, I will go into my math lab and I will unassign the homework, and then I'll omit the grade for it. So if you didn't do it at all and you had a 0, well, that 0 goes away. If you did it and you got to the cutoff score on the homework, but you never did get to it on the quiz, then I'll put that in as your quiz score. All you need to do is let me know, look, I did the homework, the quiz was just stressing me out, I like being able to go through the homework. Because the point is, it's there for you to review. The quiz is just for you to gauge, do I really need to do all that homework? Can I just do this quiz? Okay, so as long as you get the benchmark on the homework and the quiz, either one, I'm gonna put that in as your quiz grade. And it does count at the end of the semester, which turns out to be a good thing, because usually the quiz grades are good. But I drop the homework grades because not everybody needs to do it. Okay? And while I'm here and thinking about it, let me go ahead and change those due dates.
So I'll be able to do that skills quiz together.
Yes. Let's see, this is the 24th. I'm gonna move the homework due date too, so let me give you through tomorrow to get the skills check quiz done, and I'll open the homework on up through tomorrow also. But remember, you don't have to do the homework. That's there to be a help. It's not there to cause you grief. And then I'm gonna move section 1.1's homework to Tuesday night, in case you have questions, and then, or Thursday night, I'm sorry, and I'm gonna do the same for 1.2. And if we don't get as far as I think we should today, then I'll move it out a little bit further. And we should do 1.3 on Thursday, so I'll move that on out to the 29th. Chapter 1 review homework is not assigned. It's not supposed to be. But the review quiz is, and it is due the day before the test. And the post-test is not assigned either. And then if I see that these need to be modified, I'll modify those. Okay. So we should be ready now to go in the PowerPoint and try to finish up chapter 1. So, just a quick review, and I'm actually going to cut away to this screen to actually do this problem, so let me bring that up. Because I'm going to remind you, something I noticed when I was checking the homework, some people are still a little bit confused about this, so we're going to go through this again. This gives us a formula for slope, and it says find the equation of the line through the point 5, 4. So I'm gonna use the 0.54 over here, and I'm gonna make it in blue. My marker's about to croak.
I think you're stuck on the,
We are, I'm just copying the problem right now.
oh, okay.
And then we have another point that is -10, -2. And we have a slope formula. And we're gonna find the example. And I'm not going to use the point slope form for this one. I'm gonna use the slope intercept form. You're welcome to use the point slope form. It's fine. And I can go through that one too if you want to. But the main thing I want to do is show you how to do this slope, because some people are still getting their points crossed up. So let me pause that, and this is what we need to look at. So these are the 2 points we've got, and we actually want the equation of the line. But first we need to get slope. And slope is the difference in the y's, and what I want you to understand is that you have to get the coordinates of the points together. So if I want to start with this point, then I put the y on top and the x on the bottom. And same thing here, I put the y on top and the x on the bottom. You want to keep your points together. This point's coordinates need to be together, stacked up on top of each other. But the y's have to be on top. And this point's coordinates need to be together. And the y has to be on top, but they're stacked up straight over each other. You don't want to cross this up where 4 has 10 underneath it and -2 has 5 underneath it, because then you've swapped the position of which point was first and which point was second. And what you wind up with is a slope that has the wrong sign. Okay? So really the only thing you need for a slope formula to remember is it's a fraction, because it's changing y over changing x, and change tells you you're going to subtract both of those. And then if you have a negative number you're going to subtract, then you need to remember that if you subtract a negative, that's going to become positive. So then your slope is going to be 4 minus -2 is 4 plus 2. And 5 minus -10 is 5 plus 10. Which gives us 6 over 15. And 6 over 15, if I divide both 6 and 15 by 3, because they are both divisible by 3, then my final slope is going to be 2 over 5. So that's the value of my slope. Now, if I'm going to do slope-intercept form, my slope-intercept form is y equals mx plus b, where b is the y value of the y-intercept. My slope is m, so I have 2/5 for the slope. I'm not going to know what b is yet, so I'm just bringing it down. But then I can pick either y1 or y2, either one. I can pick either one of those to be my point. I'm going to pick the first one just because. This is my x value, this is my y value. So my y value coming down here is going to be 4, and my x value coming down here is going to be 5. So you take one of the points to get an x and a y, and then the only thing you have left in here is b. What is b? Well, it's easy enough to figure out what b is now. We say 2 times 5 is 10 over 5. And 10 over 5 is actually 2. So 4 equals 2 plus b, and that means then that b is equal to 4 minus 2, which is 2. So the other piece of information I needed to write my equation, I now have. B is equal to 2. And going back to y equals mx plus b, m is 2/5, and b is 2. And there's my equation. Now, if you want to use slope-intercept form, then you basically have to do the same thing with a different formula. You're still going to have to plug in the slope. You're still going to have to plug in the coordinates of one of the 2 points like I did here, and then go through and apply your distributive property and then solve the equation. It takes several steps. This actually takes fewer steps than using slope-intercept. And that's why that's the one that I teach in class, even though the slope-intercept formula is there and you're welcome to use it. But this is actually an easier, less lengthy process.
So you're kind of a professor who says whatever you're more comfortable with.
Whatever you're more comfortable with.
Thank goodness, because last semester they want you to know this way, and it's too much.
No. My goal here is to prepare you for when I see you in a future semester in business calculus. And in business calculus, the first thing that one of my students would tell you is the algebra that you learned in finite is good if you're going to try to simplify your answer, but she wants you to show her the first step, that's the calculus. She doesn't care what you do with it after that, right? I want to see that you know how to do the process and arrive at the goal. The steps in between, for some people there's more, for some there's less. It depends on how far you want to go with it. But for this is okay. Slope-intercept's okay. If you want me to show you that both methods in class, all you have to do is ask, or if you want me to, come to me in my office and say, look, I don't understand what you showed me in class. Can you show me a different way? And I'll do that just for you. Because I usually know 3 or 4 different ways to get the right answer to a problem.
Okay.
There's a lot of ways to get from here to Bristol.
Yeah,
Some of them are longer than others, but there's a lot of ways. That's right. That's right. I had 2 children and I had to explain everything differently to both of them because they learn differently. Okay, so back to the PowerPoint. We got the right equation. So now we're going to do another example. And again, I'm going to turn to the overhead. Even though I can click through the PowerPoint faster, I think I need to actually work through the problems with you so that you get it. I won't do this as much on a review. I'll probably just go through the PowerPoint and, to review quickly. But this is where I'm thinking that you're learning it. So once again, we're going to go through the same process. This is going to turn out to be a horizontal line. Okay? Find the equation of the line through 8, -4, and -2, -4. So I'm going to first have to find that slope. So all I'm going to do right here is I'm going to copy those points over just like I did a minute ago. So here's my points, and remember my formula says that I keep the points together with the y's on top. So -4 is the y, 8 is the x, -4 is the y, -2 is the x. My slope formula says that if I'm subtracting a negative, I'm going to add. -4 plus 4 over 8 plus 2. And it turns out that the slope of this line is going to be 0. Now, in this particular instance, I'm gonna go ahead and proceed like I don't know what that means, but eventually I want you to understand what that means. So we're gonna go through y equals mx plus b with a slope of 0 and see what happens. So the slope is 0. I'm going to choose this point. Zero times 8 is 0. -4 minus 0 is -4. So b is -4. So the equation of my line then through those 2 points is y equals 0x plus -4, which is the same as y equals -4, because if I multiply 0 times x, x disappears. So I get the line y equals -4. And if you graph that line on your calculator, you're going to notice immediately that it's not a slanted line. It's a horizontal line. Anytime the slope turns out to be 0, you get a horizontal line. And you can graph it on the calculator, but you should also notice that all you need to do to know what the graph is look at your 2 y coordinates. That tells you what the value of y is going to be. So the line y equals -4 comes from that pair of -4s. When your y values are the same, that means no matter what x is, y is always going to be the same. Okay?
I have a question. When I was trying to do the steps that we did the first time, like the first is find slope.
Mm-hmm.
So is the equation actually y equals -4?
Yes.
Okay.
The equation of that line is actually y equals -4. It is also this, but because the slope is 0, 0 times x disappears.
Okay.
And so all you have left is the y and the -4. Okay? So I actually do have it on the PowerPoint. You've got the PowerPoint slides in D2L if you want to go back and review. And I did it using the point and slope form too for the people that, you know, that want to do it that way, but I don't always do it in class both ways. So the key here is that when you have a line that the slope turns out to be 0, that means it's a horizontal line. And k is going to be the y value of all the ordered pairs, and the 2 pairs you've got has the same y value. So you can actually write the equation without having to go through all this work we just did. You can look at those 2 points and say, oh, your y values match. Your slope is going to be 0. Let me just go ahead and graph that line or say that the slope is 0. Now, number 7 is similar, but not exactly the same. So we're going to work through it. Because example 7 turns out to be a vertical line. And we're going to see how you know it's vertical just by looking at the points. So the 2 points we have, once again, are 4, 3. And 4, -6. And then I have my slope formula. And you see that I don't really write out y minus y1 and all that stuff, because I know that what you're really doing for slope, it's a fraction, subtract the y, subtract the x's. So I just draw the fraction bar and make the 2 subtraction signs. And then I put in my points. 3 over 4 -6 over 4. And I know when I subtract a negative that this is going to be 3 plus 6, which is 9, and 4 minus 4, which is 0. And division by 0 is undefined. That's one of the 10 math commandments. Thou shalt not divide by 0. Okay? No division by 0. That means your slope is undefined. Okay? So, quick review. This line and this line m is positive. It's greater than 0. This line, m is negative, meaning it's less than 0. This line is horizontal. The slope is equal to 0. But the situation that we've got here is this line, or any other vertical line. Okay? Those are vertical lines. And it is not that they have no slope. I mentioned last time, I think, do not refer to any slope as no slope, because that means different things to different people. In some people's head, no slope means 0. In other people, it's like no slope is like there's no slope. It's straight up and down. In order to make sure that we don't get confused, m equals 0. That's a horizontal line. The slope of a horizontal line is 0. M is undefined. That's a vertical line. The slope of a vertical line is undefined. There is no change in x. X is always the same no matter what y is. And if we tried to do it, y equals mx plus b, we don't have any way to do anything with this. So this one, you just kind of have to know that when you get an undefined slope line, that you need to go back and look at your x coordinates, because the x is going to tell you it's x equals whatever that number is. Okay? So here again, if you plotted those two pairs on a graph, you would see that they line up over the top of each other, and you have to draw a vertical line. And it's going to be important that we recognize when you have a vertical line, because when we talk about functions in the next section, we're going to find that all y equals mx plus b lines are functions, but x equals a number, x equals a constant, no matter what that number is, that's not a function. And the reason it's not a function is because x corresponds to every single y there is. It's just a very, very polygamous little scudder. It wants to marry up with all the y's, and that's not allowed. If we're talking about a horizontal line, y has lots and lots of x partners. So basically y is the destination for lots and lots and lots of different partners, people. So this is a summary basically of what we've gone through. You will have all of these formulas right here. You will have all these formulas that you need on the test. I don't make you memorize formulas. I think it's foolish to memorize things that you can look up. Okay? I don't memorize anything. I have no idea what my daughter's phone number is. Her name is Brandy. She's in my contacts. If I need her number, I go hit her name and it calls her up. And we're going to do one example problem in this section so that you understand that this stuff really is good for something. In recent years, the percentage of U.S. population age 18 or older that smoke decreased at a roughly constant rate from 20.9% in 2005 and down to 18.1% in 2012. And this is actual data from the CDC. We are supposed to, number one, find a linear equation that models the percentage of this population. And then the second thing we're going to look at is one of the objectives of Healthy People 2020, which is a campaign of the U.S. Department of Health and Human Services, is to reduce the percentage of U.S. adults who smoke to 12% or less by the year 2020. So does the model tell us that they're going to make their objective? We're going to start out with part A. And so that you can see what I'm doing at the same time you see the slide, I'm going to try to do this way. This way we can both see what's going on all at one time. Okay, so we're going to work this problem. First thing that I'm going to notice is that I've got two ordered pairs, although it might not be obvious, I do have two ordered pairs. My ordered pairs come from in 2005 the percentage that smoked was 20.9%. And I'm going to put that as a decimal because, well, I'll leave it as a percentage because you can do that here. You don't always have to change percentages. So that's 20.9%. And then a little further down the line in 2012, that percentage decreased to 18.1. And I need to find an equation of the form y equals mx plus b, where y corresponds to the percentage of adult smokers and x corresponds to the year. Okay? So the first thing I need to do is find the slope. So for my slope, I put the y's on top and the x's on the bottom. And then I do the arithmetic. So 20.9. I thought that looked a little weird. So 20.9 minus 18.1. So that is a 2.8% decrease. And 2005 to 2012, since this is larger, that's going to be -7. And it just so happens that 2.8 can be divided by 7, and so can -7. So if I divide 7 by 7, I get 1. And 2.8 divided by 7 is 0.4. You can use your calculator, double check that if you want to. So my slope is -0.04 over 1, and that is -0.04% over 1 year. So the meaning of that slope is that
Why do we divide that by 7?
just to be able to get it down to 1 year and be able to have a percentage per year. And you can actually do that on your calculator. Let me take a little sidestep right now and go ahead and do that. If you've got negative 2.8 divided by negative 7, and you go to math and choose fraction, it tells you it's negative 2/5, but negative 2/5 as a decimal is negative 0.4. Okay? So I just basically skipped over the section where we had to actually do anything with fractions. You can get to the 0.4 by using your calculator. And the reason it's important to see it this way is because the percentage of smokers is declining. And the reason we know it's declining is because the slope is negative. And it's declining by .4% per year. So slope actually has a meaning in context. It's not just some math answer or some algebra answer that you came up with. It has a meaning in context. So now that we know the slope, we need to find B, the year. So in order to find that, we're going to go back to our y equals mx plus b. But we're going to plug in the slope. Which is negative 0.4. We're going to pick one of the points, and again, it doesn't matter which point, pick whichever one you want. I usually just go with the first one. And this is x, and this is y, and what I don't know is b. So I'm going to slide right on up here and say, okay, what is negative 0.4 times 2005? And that's negative 82. So if that's negative 82, I need to take 20.9 minus negative 82 or plus 82, whichever way you want to look at it. And I get 102.9. Yes.
Are you like negative 802?
Yes, it is. Thank you. I didn't notice that my second one didn't click. That answer might not have made a whole lot of sense here in a minute either. Wow. Okay. Very, very different answer. Well, no, and that's not right either.
Really?
Let's start back from the top. Okay. Our slope is 2.8 divided by negative 7, which is negative 0.4, times 2005, which is negative 802. So negative 802, if I add that to both sides, all I have on this side is going to be B. And 802 plus 20.9 is 822.9. So my equation is y equals slope, which is negative 0.4, times x plus 822.9. So there's my answer to part A. And since I pointed out to you what this means, this also has a meaning. It's kind of a strange meaning because remember, this is years. The year 2005, the year 2012. Well, this is the year 823. Okay? Not 1823, 823. I'm pretty sure people didn't smoke cigarettes then. Okay? But that's really what that means. And we'll talk a little bit about how we can make that have more meaning by doing some other things. But right now, we're just going to leave the equation the way it is, and we have answered part A. There's our model. And then in part B, it says one of the objectives of the Healthy People 2020 is to reduce, by the year 2020, the percentage that smoke to less than, equal to or less than 12%. Okay, what they're wanting us to do is plug in the year 2020. Okay, so part B, X is going to equal 2020. Y equals negative 0.4 times 2020 plus 822.9. And we'll grab the calculator and do the arithmetic. So we got negative 0.4 times 2020 plus 822.9, and that's 14.9. So smoking did decline, but not to less than 12%. So they will not reach their goal. It's still going to be over 12%. Okay? So that means on the average, the percentage of adults who smoke is decreasing by 0.4% per year, but an estimated 14.9% of the adult population will still smoke in 2020. So the objective of Healthy People 2020 will not be met. Okay?
How would you know what's the big for Y for research, the Y's percent of adult smokers? Like, if they gave you the chart, like the numbers, do you just have to logically think about it, or is there some clearly wording to let you know?
You mean for this part?
Yeah, for where you have the year and percentage, you just have to think about it. You know that it's which one plugs in with, like
Well,
values.
you have to think about it, and this is something we'll talk about a lot in this, because this is applied.
Yeah.
You have to think about, you know, what controls what? Does the year control the percentage, or does the percentage control the year? Okay, so for each year, there's a different percentage. You could have the same percentage for 2 different years,
Yeah.
but for each year, there is a percentage. Okay? And that has to be where Y and X, they have to be in a function relationship. Okay? Now, the other thing that the slide here did, I stuck with straight information right out of the problem, but I'm going to back up here on the slide a little bit. And it says, let T represent the time in years with T equals 0 representing the year 2000. Okay? Now, you'll see in just a second, if you'll watch here, why you might want to do this. I didn't make you do this because that was something that I might throw in and throw you off of the process of, you know, how do you take data and make an equation out of it, and that's what we were already doing. This is one more step to make your life easier. If you let T equal 0 represent the year 2000, then 2005 corresponds to T equals 5. And 2012 corresponds to 12. So when you do your slope equation, the numerator didn't change. But the denominator, and I swapped the points this time to show you that you still get the same slope. 12 minus 5 is still a change of 7 years. And your change in percentage is still negative 2.8, so you still get the same slope. But then when somehow I think I duplicated something I did not intend to. Where did my equation go? I was going to show you that, but not yet. So anyway, I'll turn out to have the same equation, and I'll come back over here and show you how that works. Show you what changes as we go down through here. So instead of having 2005, I just have 5, and instead of having 2012, I have just 12. What's going to change is the value of B. Okay? So this did not change. But now that I have 5 and 12 for my X values, I'm going to choose this point just because Y is 20.9. And X in this case is going to be 5. So negative 0.5 times 5, I'm sorry, negative 0.4 times 5. Is negative 2. And if I add 2 to both sides, I get 22.9 equals B. So my equation becomes Y equals negative 0.4x plus 22.9. Okay? And Y is the percent of adults who smoke in year X, or more plainly, X years after 2000. Okay?
So you would just plug in 20 for the next one.
Yes. And in this case, you would let X be 20, Y equals negative 0.4 times 20 plus the 22.9.
Can you move that up so I can see which is right?
Oh, sorry. So negative 0.4 times 20 plus 22.9 still says it's 14.9%. Okay? But this model is a little bit simpler to think about because this is how many years after 2000. Okay? And that makes more sense than that 800 something you're thinking, what is that? Okay? That process that I just showed you is called scaling the data. And what scaling the data does for you is when you have big input values for X, like years, which are 2005, 2012, 2015, if you can scale those down to where they're either single or double digit numbers, it makes the arithmetic easier. And sometimes it makes the model itself make more sense to do that. So we'll always scale the data. Now the other thing I showed you on here is really just a shortcut. And the reason I'm showing you this here is because we're going to use this a lot in section 1.3. You can use the information that we have and find the equation of the line strictly using the calculator. What you're gonna do is you're gonna first hit your stat button. Let me see if I can make it a little bit bigger and I'll put it back to the other side. So you hit your stat button. You hit enter to choose the spreadsheet that's edit. If there's stuff in there, I'm not going to show you the quick way because in the long run somebody winds up deleting their list and I don't want to deal with that just yet. So if you've got things in your list, you can just keep hitting your delete key and they'll all go away. There is a better, faster way to do it, but we'll worry about this now. So now that I've got two empty lists, enter the coordinates of your points in the two lists. X goes in list 1, Y goes in list 2. So my 2 points are 5 and 20.9. And then my other point is 12 and 18.1. And then it says, press your stat button again and go over and choose calc, which takes you here. And what we're going to do is on the calculator, we're going to choose number 4, linear regression, which is what it says right here. And then once you've done that, you hit enter, or you just press the number 4 key, and you get this on your home screen, and you need to give it some information. The information is, where are the X coordinates of the points? They were in list 1. And on your calculator, list 1 is above the number 1 key, L1. So you hit the second button and the 1 button, and it says list 1. And then you have to enter a comma. And then the second thing is, where are your list 2 values? That's the Y values. So second and the number 2 key. And we could actually hit enter right here and now and be able to write the equation off what we see on the screen. But later on I want you to be able to store this, so I'm going to add that one last step to get Y1 after you have a comma there, because you need a comma between everything. To get Y1, Y1 is a variable. Down here next to clear, you see VARS, that's variables. Okay? That's a variable. And you go over and you choose your Y variables, and then you choose function, which is the first thing on there, and then you choose Y1, which is the first thing again at the top, and now your screen's going to look like this. And I walked you through all of those screens on the next calculator screen. So now if I hit enter, this is what I see. The fact that you don't see the R squared and the R, don't worry about it, because that has nothing to do with anything we're doing in here right now. Okay, you don't need to see those. Basically, this is telling you that your equation is y equals negative 0.4x plus 22.9. And if you press your y equals, you'll actually see it written out that way. Okay? Yes, that's very nice. And the other nice thing about it is that if you go to your home screen, and again, hit your VARS key, go to YVARS, choose function, and Y1, if you'll put in parentheses after that equation the year 2020, which is x equals 20, and hit enter, it'll do your arithmetic for you. Yes. Okay, let me come look.
I didn't catch that last thing that you just did.
Okay, let me pop the next screen up for you. If you can just follow those.
Okay.
somebody's messed with it, pressure staff. And go down to the bottom where it says set up editor. Hit enter. And then hit it on one more time, and you'll see list one and list two, and go back to staff. And that's why I wouldn't show you how to clear out the list quickly, because that's what happens when somebody does it the wrong way. They delete the list instead of clearing the list.
Thanks, April.
Okay, first of all, let's turn that off. Go up here where it says plot, up arrow. Go over to that one. Yeah, hit enter. That needs to be turned off. Now hit your stack, well, quit from there. Hit your stack buttons. Now, number 5, set up there. Enter twice. And you should be good to go. Okay, so when you go back to stack, you'll see all the lists.
Can you find this PowerPoint online on D12?
Yes, yes, these will be in D2L. These will be in D2L. Now, this first section actually is a lot longer than I intended for it to be. So if we get a little behind on this first section, we're gonna make up for it later. So don't worry, I'll adjust due dates. You may not be able to do everything just yet. But I'm taking a lot of time up front with you because we want to learn to use the graphing calculator throughout this course, because it's going to be very handy in your calculus class. Okay, so I want you to have good calculator skills. Now, the other way it says that you could actually go over and look at your table and enter in the value there. There's lots of different ways to do this. What you do is you go to your table setup. Doesn't matter what these two say, what you want is independent to say ask. Okay, you can always build a table of values on your calculator. And now that you've got your equation right there, all you do is go to second table, and I've got a bunch of stuff in there that I'm gonna, well, I guess I'm gonna delete it out. Because there's no way to clear the X's out quickly. And I just want to know for the year 2020. And it does the arithmetic on the table as well. So if I had other questions, it says, when will it drop below 12%? Well, 21, 22, 23, 24, 25, 26, 27, 28, 29, and I see now at 2029, I'm finally below 12%. Okay? And I will have this up in D2L so that you can see it. Please do not print out the PowerPoints. If you want a printed out copy of the PowerPoint for any reason, send me an email or text me through Remind, and I will post the file that you can actually print out. If you don't want to print out, 58 pages worth of PowerPoint slides. Okay? I'll send you a file that has them 4 to a page. Okay, graphing lines. I need to gauge how fast or how slow we need to go through this part. How many people can graph a line if I give you the equation on the calculator? No? Kinda? Okay. We've got about 3 minutes left. I'm going to get through this first example with you, and then I'll finish going through this next time. We need to graph y equals -3/2 x plus 6. I'm going to do it again over here on the side. This one, I might not do them all, but this one I'm going to do over here on the side so you can see what I expect you to do. You have an x and a y axis. I don't see my ruler up here. I would be using it because I usually can't draw that straight a line. So I expect you to use graph paper to do this. I expect you to label your axes and somehow show me what your tick marks represent, which doesn't necessarily mean that has to be 1, 2, 3, 4, 5. You can go 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5 in the negative direction. 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and so forth. The +6 tells me that the point 0, 6 is the y-intercept of that graph. 0, 6 is start at 0, don't go right or left at all, move 0 from 0, and then go up to 6. And then the rest of the equation is y equals -3/2 times x plus 6. And we're going to use the -3/2 to go from 0, 6 to find the second point. That means we're going to have to change this either to -3/2 or 3/-2. You have to assign the negative sign either to the top or the bottom. So from here, if I'm using the slope -3/2, that tells me I go down 1, 2, 3, and then forward 1, 2. And that gives me my second point. And then I draw my line through that point. So if I had a ruler, and I'm going to pretend this is a ruler even though it's not, I line those 2 points up and I draw a long straight line. I put arrows on the end of it because that line would continue to behave that way both directions. So this is the line y equals -3/2 x plus 6. Okay? Now if instead I had chosen this slope instead of the -3/2, 3/-2, then I would have counted up 1, 2, 3 and left 1, 2 because that's -2, and I would have gotten that point instead, but it's still on the line. Okay? Yes, ma'am.
For that, I understand what the graph is, but the information, that's in the calculator form right there. You can go in and simply.
You can go in and graph it on the calculator, and you can, I'll show you again later on when we do another example, how to pull information off your calculator and actually sketch a graph.
That's what I just did.
Yeah.
But is that okay?
Yes, yes, that's fine. That's what that's my goal is to actually get you to graph it on the calculator to help you sketch a graph. We don't really necessarily always have perfect graphs.
Okay.
Okay? See you on Thursday.